talking about something if you know what the word is, okay? So when you have a polynomial, we've seen this definition before that says a polynomial is something like a sub n x to the n power plus a sub n minus 1 x to the n minus 1 all the way down to your a sub 1 x to the first and your a sub 0. It's just those a's just represent coefficients. X, those powers are decreasing. So a polynomial is basically just adding and subtracting a bunch of powers of x. When I talk about the degree in our polynomial, what is the degree? The highest power. In this case, it would be n, just the biggest exponent. What are those coefficients?
The number independent.
So all of those a's are coefficients, those numbers in front of my variables. What's the constant? The term without a variable. So in this case, it was that final a. What's the leading coefficient?
The number that has the highest or the highest
Coefficient of the term with highest power. And the leading term is just the term with the highest degree. We've seen some of these terms before, so they're not all new. We've talked about degree, we've talked about coefficients, constants, so those pieces aren't really new to us. We just need to refresh them a little bit. When we are talking about a polynomial, so I've told you it's of this form, all of the exponents are whole numbers. So if it's a polynomial, you can't have x in the denominator because that's like a negative exponent. You can't have a fraction in your exponent. You can't have a decimal in your exponent. So polynomial, it's basically all the powers are nice numbers. 0, 1, 2, 3, and so on. Okay, make sure you're with me here. Filling in your notes and asking questions if there's something I talked about that you don't remember. When we look at these graphs, the graph will always be nice and smooth and continuous. There's not going to be any corners, no breaks in the graphs, no asymptotes, nothing weird here. Any transformations, there's the same rules that we've used before, so we're not learning anything new there. First thing I want to do is just look at some and decide if these are polynomials, and why or why not. So would this first one be a polynomial? I don't have any any decimals in my exponents, no negative exponents, no fraction exponents. So yes. What's the degree? The highest power? 4. It doesn't have to be the first term. Okay? It can be if it's written in standard form, but there is no reason that it has to be. So make sure you're looking at all the terms there. Okay, B is that one. A radical, square root of x, that's like saying x to what power? The 1/2. Can you have a fraction in your exponent? No. So if it's polynomial, you will not have a variable under a radical. What about C? No. if it's a polynomial, you will not have a variable in the denominator. D. Is that a polynomial? Doesn't break any rules, so yes. But the degree, careful. 0 is the same as 0x, so that would be like degree 1, but isn't 0 the same as 0x squared? Or 0x to the 10th, or 0x to the 100th? Couldn't I put any x with this? So can we say what degree it is? No. So this one, if it's just 0, it has no degree. And that is the only scenario where this occurs. Only if it's just f of x equals 0. That's the only time we can't give a degree. So E, g of x equals 8. Would that one be a polynomial? Yes. Now this one, my degree, okay, if I put an x with it, that's different than just 8. If I were going to put an x, it would have to be what power? 0. Because anything to the 0 power becomes 1. So if it's a constant, your degree is 0. There are no x's with that term. A degree is like saying how many variables are in the term. So just a plain number, there are none. Okay. Last one. Would that one be a polynomial? Yes. My degree, the degree is the highest power if your terms are just added together. So we have to think about if I multiply this whole thing out, what degree would I get? Now, I don't really want to multiply the whole thing, but we don't have to. We want to think about the highest degree. We have an x cubed here. If we FOIL this, we'd get an x squared. So overall, we'd have x to the, what's x cubed times x squared? What do you do with those exponents? Add them. So your degree is 5. Remember exponent rules? If it's written like this, that's when you multiply. But if the x is written each time, that's when you add them. Okay, we'll be practicing that more as we move through here, finding the degree if it's factored like that. Alright, what I want you guys to do is take a minute, grab a graphing calculator, and just draw a really rough sketch of each of these graphs. Okay, doesn't need to be anything fancy, just a really rough sketch. So what do you notice about A and B? Okay, and what's true about their graphs? Yeah, they're really pretty much the same. The only difference is, I did not do a very good job of illustrating that there. Which one's skinnier? If I had done a good job of drawing this graph. Can you tell? X to the 5th is just a skinnier version of x cubed, if I've done. Okay, so both of these had an odd exponent. And they really look the same, except when my exponent got bigger, it got a little bit skinnier. Alright, when I look at C and D, what do both of these look like? Parabolas. What's the difference? They just get a little bit skinnier as that exponent grows larger. So what this is giving us is what we refer to as end behavior. If you just look at x to a power, if that power is even, it will look like x squared. And if that power is odd, it will look like x cubed. The only thing that's happening as that exponent gets larger, the graph narrows. It gets skinnier, but the same general shape. So this is our end end behavior slide tells us what is happening as x goes forever in the positive or negative direction. So when we go to draw these graphs, the very first question I'm going to ask you is what's the degree? And then I'm going to say what's the end behavior? And your degree is what dictates your end behavior. So when our degree was even, an x squared, an x to the fourth, an x to the sixth, what direction were both of my ends going? They were both going up when it was even. When it was an odd, an x cubed, an x to the fifth, what's happening with the ends? One going down and one going up. Okay. So if you were to look in the book, they do say like f of x goes to infinity as x goes to infinity and that type of thing. We're not going to be quite that precise. So it is decided by the leading term. If the degree is even, then what that means is as long as it is a positive coefficient, we're just going to draw two arrows. Both ends were pointing up. When we looked at the x squared, the x to the fourth, x to the sixth on our calculator, both ends were pointing up. Now, what if it were a negative coefficient? What if I said negative x squared, negative x to the fourth, negative x to the sixth? Then it's upside down. So then, both ends going down. If it's an even degree, the ends are going the same direction, and whether it's up or down is if the coefficient is positive or negative. So if we have an odd degree, then if it's a positive, it's going to look like our x cubed, which the left side was going down and the right side was going up. But if we had a negative, what would happen? It would go up, down. It's just going to flip. Alright. So far so good? So we're just going to practice looking at some and deciding the end behavior. When I look at this, all I need is the first term. My degree is odd, so what does that tell me? It's going to look like a cube, normal cube. And it's a positive, so nothing's flipping, so my end behavior would be down, up. Alright. Next one. The only thing we look at is the term with the highest power. Doesn't have to be the first one, so you just have to look through and find the term with the highest power. Okay, even power tells me it looks like a parabola. But the negative in front will do what? So, end behavior would be down, down. See. We could multiply this whole thing out. We really don't have to. We just need to think about, okay, if I were to multiply the highest power of x, I have a 3, this one has an x, the last parenthesis would end up with an x squared. So when I multiplied those, we would get 3x to the third. Okay, and that's all we need to decide our end behavior. So what would it be? Down, up, down. Last one. Okay, I really don't want to multiply this all up. We'll be here for the rest of the hour trying to multiply all this. But if we're looking at end behavior, all we care about is that highest power, that term with the highest power. So we have a 1/2. This parenthesis would give us an x squared. And this parenthesis, if you have an x squared cubed, that would become x to the 6th. The last one would be an x to the 4th. So overall, we get 1/2 x to the 12th. So what would that look like? Regular parabola, it's a positive coefficient, so both ends are pointing up. Is everybody understanding how we're getting these? Now what if you forgot, or you got confused, and you couldn't figure out what the end behavior should be? How can you figure it out? Do you have a graphing calculator? Yeah, could you look at that graph and tell me which direction the ends are pointing? Yes, that's an option to double check yourself, so take advantage of those resources. Alright, we've done some of these already, but let's practice some more. We had them on our last assignment. When I gave you the 0, and I want the polynomial, degree 3 means we should have 3 zeros, and I gave them all to you. It's next to the 3rd. So if -3 is a 0, what should we have? If 2 is a 0. If 5 is a 0. Alright, is that degree 3? Yep, I didn't give you any other requirements, so you're done. That's my polynomial. Right. B. If 0 is a 0, what would we have? X plus 0, or x minus 0, or just plain x. So any of those three would be fine. If 4 is a 0, we need, if 12 is a 0, now I said degree 4. What's my degree currently? 3. So without adding any other zeros here, how could we just add an exponent to one of these? What would I need? What power would I need to put? Just squared. There's 2, 3, 4. Now is it degree 4? Yes. Is this the only correct answer? No, because I didn't tell you which one had a multiplicity. So since I didn't give you that, you could have put the square on any of those. That one didn't give us quite as much information as we're used to. Alright, C. Degree is 3. If -1 is a 0, that would be, and if 1 is a 0, and if 2 is a 0, okay, there's my degree 3. Y-intercept is 1. It's kind of like giving you a point. When you're on the y-axis, what's your x? 0. It's saying 0, 1 is a point on the graph. Didn't we have some of these on our homework? We said there might be a number out in front. We have to find that number. And so to do that, we're going to plug in the 0 for our x's. So 0 plus 1 is 1, 0 minus 1, 0 minus 2. And that whole thing equals 1. So we get 2a equals 1. So a is 1/2. So in order to meet the requirements given, having that y-intercept, we did have to find the coefficient this time. So those were on the homework a couple days ago. Just kind of refreshing our memory here. I'd like to get through just a few more slides and then we'll probably stop for today. So some of the terminology I might be using, when I talk about a 0, that's just the number. So we were doing that on the homework. We were listing the zeros and we just said 5, 2, -1. When I talk about the factor, that's when you do the x minus each of those. So a factor has an x with it, 0 does not. We know on the graph a 0 is the same as an x-intercept. or it's basically saying that when you plug that number in, it makes the whole equation equal 0. So all of these things are really asking for the same thing. If I said find the x-intercepts, or find when the equation equals 0, or find the zeros, those are all the same. The factor is when you put the x with it. Alright, so we had one of these on our homework the other day. Why don't you guys try this one? Give me the zeros and the multiplicities here. Does the 5 ever equal 0? No, so that's not helpful. What makes x minus 2 equal 0? What makes x plus 3 0? And it was squared, so that means multiplicity 2. What makes x minus 1/2 equal 0? 1/2. It was to the 4th, so that means so B. If I just have an x out in front, what makes that 0? 0. What makes x plus 1 0? 1. 3x minus 2? Yep, you can always, if you ever get one that you're not sure about, just work it out. You get 2/3. That one was to the 3rd power, so that's an x minus 5. Now we know that these points are what on the graph? Yeah, so like this first one, it would hit the x-axis at positive 2, negative 3, and positive 1/2. And those are the only places it hits the x-axis. What's the total degree of this one? You can either count the powers or count how many zeros we got out. 7. We have an x squared, and x to the 4th, so it's a degree of 7. So odd degree, what should my end behavior be? Should look like a cube, down, up, right? So we already know that this graph starts down here and ends up here, and these are the only places it hits the x-axis. So we're kind of getting all the information we need to draw these graphs. The one thing we need to talk about is how does the multiplicity factor into this? And when I see a multiplicity of 2 or a multiplicity of 4, what does that do to my graph? So that is the next piece that we're going to mention today. What happens is if it is an even multiplicity. Okay, think about, for example, just y equals x squared. We know that's a parabola, right? The only 0 there is 0, and it has a multiplicity of 2. And what happens to the graph when it hits there? It hits 0 and it bounces back up. When we had x to the 4th, it hit 0 and it bounced back up. When you have an even multiplicity, your graph will bounce at those zeros. So if it's even, the graph bounces. Okay, in other words, you have your 0, you will hit it and just bounce back off. If it's an odd, think about like when we had x cubed, x to the 5th, x to the 6th, or x to the 7th. It just went through that 0. So if it's an odd multiplicity, the graph will just go through that point. So that means we really know everything we need to draw a graph of that polynomial. Now if I'm looking back at the one we just did, okay, -3, my graph started down here. -3 had an even multiplicity, so what should my graph do? Bounce. Okay, we have to come back, we have to hit it at 1/2, and 1/2 has an even multiplicity, so it should bounce. We hit it again at 2, which has an odd multiplicity, so it would go through. And did it end the direction we said it should? Yes. Now, is my graph real precise? No. All I have is the correct shape and x-intercepts. But that's what we're going to be working on tomorrow. Taking the zeros, the degree, the multiplicities, and drawing a graph from those pieces of information. So last thing that I'm going to mention today, and then tomorrow we will just pick up drawing these graphs. I want to talk about turning points. If I look at this, if I didn't tell you what a turning point was, what do you think it would be? Yeah, where it turns around. We were increasing and we switched to decreasing. There's a turning point. We were decreasing and I switched to increasing. There's a turning point. Here's a turning point. Here's a turning point. So turning point is just where your graph changes direction. In general, the number of turning points your graph can have is at most the degree minus 1. So if the degree is 7, what would be the maximum number of turning points we could have? 6. We don't have to have 6, but that would be the most. Likewise, if I'm looking at a graph and I say, okay, this has 4 turning points, the degree would have to be what? 5 or more. Okay? So the last part of your homework today is just going to have you looking at some graphs and deciding which of these equations it could be. So you need to count those turning points. If it has 4 turning points, can it be an x cubed? No. Your turning points has to be smaller than the degree. All right. So I'm done. There is a handout posted on Classroom, so you can work on that.